Okay, so we're going to begin discussing together today acids and bases and the myriad differences and similarities between the two. We're going to start by talking a little bit about acids and sort of their primary characteristics. There are a couple of different kind of working definitions for both acids and bases. So before we get into like all of the heavy terminology, I think it's important to just understand on some level fundamentally what an acid is, what a base is, why it interacts with things the way that it does. Okay, so let's get started. Um, Acids, to begin with. In the first place, acids, when they are aqueous, right? So when we take an acid, like let's say hydrochloric acid, HCl, and we put it in some water, right? So when aqueous, an acid will conduct electricity. And what we've found is that in general, the more ionized that aqueous acid is, the more conductive it is. So for instance, we know that hydrochloric acid, because it is a strong acid, disassociates in water into hydrogen cations and chloride anions, right? And that again is what's called ionization. So the more completely something ionizes when it's in water, the more conductive it will tend to be. The second thing that we know about acids is that they do tend to react with active metals. Again, this is with active metals as opposed to say like, transition metals or something like that. So this will be like, groups 1 and 2, think. So active metals to liberate hydrogen cations. Another thing that we know about acids, and this might seem kind of obvious to you guys after all of our experiments together, but it's an important characteristic, is that acids will change the color of indicators, of sort of key indicators like the ones that we have used together in labs. They will also have a tendency to neutralize bases. And this is actually something that we will talk about a little bit more together in here, and we'll talk about again. It's also something that you guys know about just from our lab protocols, our lab safety protocols, right? You know that when you put a strong acid together with a strong base, so like vinegar and baking soda, right? If you put those two together, what you're going to get is a salt, which tends to be neutral, and some water, right? So it's very important that we understand that acids and bases, when they are combined, will always cancel each other out essentially. Strong acids and strong bases anyway will do that and have that effect on each other. Another sort of characteristic combination that we will tend to see from acids, right, is that they can be combined with carbonates. They will react with carbonates to release CO2 gas. Fantastic. Okay, so now let's sort of shift over to the other side of our table here and talk a little bit about bases. So bases. Through the magic of cutting and pasting, I'm able to express for you the fact that bases will also conduct electricity in the way that acids do, and will tend to do so more when ionized than when less ionized, right? Another thing that acids and bases have in common, as it turns out, and bear with me here. So the second thing that they both have in common is that they both will change the color of an indicator. Oops. So they both change potentially the color of an indicator. The third thing that they have in common, right, is that they both neutralize. They both neutralize. So again, if it is true that acids neutralize bases, bases in their own way neutralize acids. And again, they do that simply by creating salt and water where before we had an acid and a base. There are a couple key differences, however, between these two items, right? Aside from the fact that they're kind of like classic opposites of each other, right? For instance, you might not be 100% aware of this, but bases react with fats to form a class of compound called soap. And if that is surprising or weird to you, I will recommend to you the scene from Fight Club in which soap is produced using lye and fat. Or, better yet, don't watch that scene. It's actually really gruesome. Maybe watch something that's a little less horribly violent. But I promise you that one of the most kind of basic and ancient chemical reactions that was purposely performed was the creation of soap, along with cooking and the making of beer and things like that, right? Other key characteristics: a base that is aqueous, a base essentially that is in water, is going to feel slippery. It feels slippery. And this one's really key for lab safety, and this is one that I try to emphasize in class as well. A strong base is very caustic. And I think this is something that we try to emphasize in part because I think everybody kind of knows just from life, right? And from like movies and whatever that acids are dangerous, right? But sometimes we get lulled into a false sense of security with bases. Bases, strong bases, are every bit as dangerous as strong acids are. Maybe more so because you're not necessarily as aware of the danger. Okay, so this gives you hopefully a pretty good baseline for the major characteristics of both acids and bases and their sort of similarities and differences, I'm going to let Sal Khan take over and talk to you guys a little bit about the various classes of acid and base: Arrhenius, Bronsted-Lowry, Lewis, conjugate bases, and things like that. And then I'll be back a little bit later to talk to you a little bit more about salts and amphoteric acid-base compounds. Okay, thanks for watching.